Hi everyone, welcome to this video lecture on the subject optical and microwave engineering. So in this lecture we are going to discuss about optical fiber communication, and let's see the introduction. So what is communication? So it is transfer of information from one point to another point. So we use modulation and also other systems for different types of communication. So we use carrier waves, radio frequencies, microwaves. So these are the some carrier frequencies we are using. So we can also use the light signal for optical fiber communication. So where light acts as the transmission medium. So you can compare these carrier signals where radio waves used as a high frequency carrier, and also microwave signal which is around 1 to 300 gigahertz, where cost of equipment is very high. So when we use light for communication, optical range frequency is used, and also it is given in the optical wavelength 800 nanometer to 1700 nanometer. So what is the importance of this optical communication? Because it gives increase in bandwidth compared to other carrier frequencies, so very large amount of bandwidth, so high data rate is possible. And also for long distance communication, so optical fibers and also underwater communication optical fibers, these are all possible. So for internet applications also it is very much useful. So generally we use communication system as transmitter, and then transmission medium, receiver. These are the basic blocks as shown in this diagram. And also for optical fibers, we have information source which should be converted into light signal, which is optical source. So this is the first part, and after that we need to transmit through the medium which is optical fiber cable. So optical fiber cable is used as the medium, and also receiver where we need convert to light signal into electrical signal. So this is optical fiber communication link. So in which what is important is the transmitter block where driver circuit light source is given, and the shaded area is the communication medium which is the optical fiber, and at receiver side we use photo detector and signal restorer. So these are the important blocks of optical fiber. And this is the digital optical fiber link. We can also use the laser driver circuit encoders at the transmitter side. And what is the receiver side detector is used means, here in this diagram you can see APD, which is avalanche photodiode, and at the receiver side we have the decoder and amplifier. And also optical fiber modes. So modes of the optical fiber depends on the propagation of light along a waveguide. So these guided modes are referred as trapped modes of the waveguide. And this is the basic structure of optical fiber, in which it has core and cladding. Core is the main transmission layer, here in which the core total internal reflection takes place, in which light travels. It is a single dielectric, and also refractive index of N1. And for cladding, refractive index is N2, which is less than N1. And also it reduces the losses and it protects the core. So this is the basic fiber structure used in optical. And why we use optical fiber communication means, I already told that it has a large amount bandwidth, and also it has a small size and weight, and it has the property of electrical isolation, and also it can immunity to interference and crosstalk. So it can give very much uh, good immunity to interference, so they can send the signal without any losses, and also signal security. So these are the important features of optical fiber communication. And what are the applications? So long distance communication, and also broadband services, and then computer data communication, etc. And we can see the types of optical fiber, where we use step index fiber, which has a core and cladding as shown in this representation, and graded index fiber. Here the refractive index vary as a function of distance. And also other modes are single mode and multi-mode fiber. So let's take the assessment. Thank you for listening.